Okay, we're going to talk about power laws. You did that in grade 9, and now we're going to have it with exponentials in fractions. Okay, so let's just recall multiplication, your power rules. So if I had x to the 5th times x cubed, then if these are same base multiplied, I add the exponents. So now if I change your exponents to fractions, it's the same concept, so I just have to add the fractions. So when you're adding fractions, the bottoms are the same, so I add the tops 4 over 2, which is actually the same as 2. 3x to the 1/3 times 2x to the 4/6. So coefficient becomes 6, x to the, and I need to add. Okay, so on the side here, I would go 1/3 plus 4 over 6. And the bottoms aren't the same, so I can't add, but I could change that to a 6. But if I do that, I would change that to a 6. Oh, sorry, to a 2. There we go. Because I multiply this by 2, multiply that by 2. I'm thinking ahead to the answer here with 6. So this is 6 over 6, or 1. So my final answer is 6x. You don't actually need to write that 1 in the exponent position. It's implied. Dividing. So if we had x to the 18th over x cubed, the rule would be to subtract the exponents. Okay, so let's see what happens with a fraction. So 5/2 is the exponent, 3/2. So here my answer would be with an exponent of 5/2 subtract 3/2, which is common denominator, so I just say 5 subtract 3, which is 2, which is x to the 1. Again, you don't need to write the exponent x. Or sorry, the exponent 1. Okay, last example in that category. 49x to the 2/3, 7x to the 9/3. Okay, so the coefficient is 7, and then I'm going to have x to the, since it's division, I'm going to go 2/3 minus 9/3. And so they actually are in the same base, so I can -7 over 3. So you can leave it like that. If I say all answers have to be positive exponents, then you would have to have that on the bottom. Okay, and the power rule. So if you recall, I'll do 2x to the 4th and then cubed. So I have to cube 2, which is 8. And then the exponent to the exponent there becomes 12 because you multiply. Okay, so here's a fractional example. So an exponent of 1/2 is the same as taking the square root. So what is the square root of 16? 4. And then I times 4 times 1/2, which is 2. 27x to the 5th, and then to the 1/3. So this exponent is the same as taking the cubed root. So cubed root of 27 is 3 times 3 times 3, right? So 3. And then I times those, so 5/3. So if you forget your fraction math, I'm just saying 5/1 times 1/3, and then saying the top is 5, the bottom is 3. Okay, I'm going to do some more examples here. 1/5 x to the 2/3 times 3/4 x to the 4/5. Okay, so I'm going to times those coefficients. So the top is 3, the bottom is 20. And then I'm going to add the exponents. So they do not have the same bottom, same denominators, so I'm going to go over and figure out what I can do. So between a 3 and a 5, I could change them both into a 15. So if I change this to a 15, I times by 5, so this would become 10. And if I change this to a 15, I would times by 3, so this would become 12. So now I add the top, and it's 22/15. Okay, so x to the 3/5 times x to the 1/4, and then to the 2/3. So I'm going to do this first, so because that's timesing, I'm going to add so over here 3/5 plus 1/4, again the denominator is not the same, so I'm changing them both to a 20. So if I change this to 20, timesing by 4, and then if I change this to 20, this would have to become a 5 because I times by 5. So 12 plus 5 is 17. So now I would times. So 17 times 2 is 34, and 20 times 3 is 60. Okay, so next. So again, 1/3 as an exponent is the same as doing the cubed root. So think about what times what equals -27. It's got to be the same thing, so -3 times -3 times -3. And in this, I would multiply because it's exponent to exponent. So -4 on the top and 3 on the bottom. Okay, so next example. Okay, so if I want to simplify this, I have to probably just remember the rule. Anything at all to the 0 is 1. So it is just x squared y cubed.